Let's get back to the details of how DRAM works and zoom in to explore a single memory cell situated in a massive array. This memory cell is called a 1T 1C cell and is a few dozen nanometers in size. It has two parts: a capacitor to store one bit of data in the form of electrical charges, or electrons, and a transistor to access and read or write data. The capacitor is shaped like a deep trench dug into silicon and is composed of two conductive surfaces separated by a dielectric insulator or barrier just a few atoms thick, which stops the flow of electrons but allows electric fields to pass through. If this capacitor is charged up with electrons to 1 volt, it's a binary 1. And if no charges are present and it's at 0 volts, it's a binary 0. And thus this cell only holds 1 bit of data. Designs of capacitors are constantly evolving, but in this trench capacitor, the depth of the silicon is utilized to allow for larger capacitive storage, while taking up as little area as possible. Next, let's look at the access transistor and add in 2 wires. The word line wire connects to the gate of the transistor, while the bit line wire connects to the other side of the transistor's channel. Applying a voltage to the word line turns on the transistor, and while it's on, electrons can flow through the channel, thus connecting the capacitor to the bit line. This allows us to access and charge up the capacitor to write a 1, or discharge the capacitor to write a 0. Additionally, we can read the stored value in the capacitor by measuring the amount of charge. However, when the word line is off, the transistor is turned off, and the capacitor is isolated from the bit line, thus saving the data, or charge, that was previously written. Note that because this transistor is incredibly small, only a few dozen nanometers wide, electrons slowly leak across the channel, and thus, over time, the capacitor needs to be refreshed to recharge the leaked electrons. We'll cover exactly how refreshing memory cells works a little later. As mentioned earlier, this 1T 1C memory cell is one of 17 billion inside this single die.